point A on the building and point B on the antenna have been measured relative to the electronic distance meter EDM at O. So the distance of this point from here and the distance of this point from here has been measured. Determine the distance between A and B. Okay. I need to find the distance between A and B. That's what I'm after, is the distance. Problem is, I can do that by finding the position vector. But there's a slight confusion here. Do I have to find position vector AB or BA? You have to be careful. It says that the measurement of A and B is with respect to O, so that we know. But to find the distance between A B, do I have to find the position vector BA or AB? Which
Sir,
one shall I go for? Is it from the, sorry,
won't the
say again?
magnitude be same for both cases?
Are you sure?
Yeah,
Yes, sir,
because the difference
magnitude.
Sir,
between
it's written
AB and
from A to
BA
B, so
is
we will have to
simply
take AB.
the
It says
direction, right?
from A to B, therefore we will find AB.
Yes.
Where is written A to B?
Sir, in the third line.
In the question
Okay,
third line.
that's okay. That's a hint. That's a hint. Forget the hint now. That's a hint. That's not part of the question.
So you
Then
could do both
Magnitude
of
same
them
one.
because
both of and
the
then
magnitude
the
doesn't
magnitude.
exactly have direction.
Distance is magnitude.
Okay, so what you're saying that
Both
if I
cases.
calculate position vector AB and find its magnitude, or find BA and then its magnitude, the answer would be the same.
Yes,
Yes.
sir.
Yes.
Yes.
Yes,
Yes,
sir.
sir.
Okay, let us find that. Let's see if that works. Okay. So what we are after, the position we are after the distance AB. So to find, I need I need to find this place, this distance. Okay. I can do either position vector AB or BA, any one. But to do that, first I need to find the position A and also the position B. I need to find that. So what I can do, I can find RA, I can find RB, just like we looked at this. Remember, if I am after the position vector R, that's here in space, what I did, I first found the position of A with respect to O, and then position B with respect to O. Once I had my two vectors RA and RB, I subtracted and got my R out. Remember, this is in the second slide. So I'm doing exactly the same thing in the exercise. Okay, where am I? Sorry. Okay, so let us, you can clearly know what is OA. Look, this is OA, ROA. It's not AO, it's ROA. Doesn't matter, I can do AO also. But ROA, so I can get my Z component is already given because I know my A and I know this angle here. So I can get so I can get this component out. Am I right?
Yes, sir.
Okay. Also, I know this angle given here. So knowing this angle, because I've already calculated this part and also this part, those two, I got it from using this and this. So knowing the projection of OA on the XY plane, that's here, and then knowing the angle here, I can get this component and this component. Am I right?
Yes,
Yes.
sir.
So, for in simple words, for OA, I've got my three components out, which are given here. You have to be careful. The Z component is positive because it's in the upward direction. The projection of it is in this direction, which tells me that it is in the positive Y. So my Y is also positive. And if I look at the X component, it is opposite in the opposite direction. So therefore, my X component is negative. So that's ROA. In a very similar way, you do ROB. Once you got your you got your OA and OB. That's basically what you found is this vector and this vector. Now you can do RAB by subtracting B from B and A, or you can find RBA. So that's A minus B. It's your call. You can do both, because in the end, you will get your values out. Your distance x, y, z will not change for RAB or for RBA. The only thing that will change is the sign here. Because for R, if you look for RAB, that's from A to B, clearly it has got a Z component upwards, so that is positive. You can clearly see that my Y component is also in this direction, which is opposite to my axis, Y axis here, and therefore that is negative given here. And if you look at the distance, that's the distance given here for your A, and this is the distance given for your B. So my X component is in this direction. That's my X component, which is in the negative. And therefore you got this negative number here. But if I had to go for BA, so that's from B to A, as from B to A. That's what I'm after then. So if I have to do this, then clearly the distance x is now in this direction, because you can clearly see the distance is in positive x. So this would convert into positive. Again, it is in the positive y direction, the y component. So this also becomes y. Y also becomes positive. And it is in the downward direction, so Z becomes negative, so this becomes negative. So the value magnitude will be the same, but the signs will change. And once you get that, you find the magnitude. So the magnitude of both are AB and BA is the same. So that magnitude is the distance. So that's how you get your distance out. Is that clear to everyone?